Let's look at our first condition to do a confidence interval. You can read this. This is the scenario. We got our 20 data values. What is the value of the proportion of voters samples that voted Democratic? As poorly stated. What do I know? I know that the sample size is 20. It said 20 random, so I'm going to just assume that's correct. It doesn't count. But in this case, success, note what are we counting is vote Democrat. Again, success is nothing good. Success is nothing bad. Success is what are we counting? So in this case, my point estimate is, well, let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Looks like I have 12 successes and out of 20, and that is my point estimate. Again, what is the general name for the value just calculated in part 1A? If the intent is to estimate a parameter, the answer is question 1, point estimate. Just notice the third time I have emphasized this. What is the name of the same value in generally? Well, generally, this is just known as a statistic. Because it just characterizes some aspect of a data set, which is what those values are. Now, is the method described to find the sample proportion have the potential to be biased as far as you can tell? What do we do here? This is stating information that voters were contacted by looking at county records. Of those who voted, the names are enumerated, selected randomly by random generator. It looks like then they're contacted by the officials. Now, it looks like the sampling process is a simple random sample. Simple. So not biased as far as we can tell. And to make clear what I mean by this is the method, right? It's the method used. Method described, is it that possibly biased? That's all we're saying. It's all about the method. Could this result be skewed in such a way that really is not representative? The answer is yes, that can happen. But the method described is not biased, which means what I just described can just be can I produce such a sample that is likely not representative? The answer is probably no. No, it's not really going to happen. Now, it could have more variability because my sample size is so small, but that's, again, another issue. And yes, of course, because the sample size is small, it could also be not as representative as you like, but a different scenario. Okay, what is the passing rate of a Stat 243 MPCC? All students in John's Stat 243 class were sampled. Below is together. So let's look at this again. Do I have the sample size? I do not. Let me count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Looks like there is 28 values. What is, again, success is pass. So remember, to find the sample proportion, you need to, even the population proportion, you need to define what success is. Success is pass course. And again, success is nothing good. Success is nothing bad. Success is, what are you counting? 28 is my sample size. And out of those, let me just go backwards here. Let me count them not passed. 1, 2, 3, 4, 5. 6 people did not pass. So it must be that 22 did pass. That is that. And again, what is the general name for this value? Just calculated. Point estimate. If the intent is to estimate a parameter. So again, look at what we're asking. What's the general name? If the intent is to estimate a parameter, let's call it point estimate. But in general, what's the name of this value? And again, it's just a statistic. Is the method described to find the sample proportion have a potential to be biased as far as you can tell? And the answer is yes. I mean, if our goal, what is the goal question? What is the passing rate of Stat 243 at PCC? Well, sampling just one person's stat class, most likely it's not going to be representative. So yes, this sampling method which as far as I can tell is grab somebody's class at random and figure out how many people in that class passed, and then use that as the estimate. So yes, the sampling method is biased. Most likely not going to produce a representative sample consistently. So what do you think is a necessary condition of our sampling method if we're attempting to estimate a parameter? And the answer is make sure sampling method is unbiased. And again, the reason for that is the following. We don't know what this value is. But when we say if a sampling method is biased, what does that mean? I'm going to really exaggerate this just to make it understandable, but and it could be this far off. I'm going to make another mark here, and this is going to be P. What I'm going to call this biased, or P, biased. In other words, if your sampling process is biased, that means that the center of your biased sampling method has a different proportion. So what does that mean? Well, here is, let's say that this is the distribution if your sampling process is unbiased. Here is the sampling distribution if your process is biased. But if it's biased, then your point estimate, let's say, lands by chance on this other side. Here, when you create your interval, it will most likely, depending how far these two are apart, contain the bias proportion instead of the actual proportion. Worse, people will say, well, if it's biased, can we just increase n? And the answer is no, it will not erase the bias. If anything, it will make it worse as I increase n. The range here, as we'll see, and you already know that as the sample size goes up, this curve, red curve, shrinks, and so does this one. They shrink. So these two will get further apart statistically, which means that all of a sudden, this is most likely to get closer to this value. And when I create my interval, it will make what I think is the location of true parameter worse off than before. So to make this work, our sampling method has to be unbiased. 2 is satisfactory degree. And what does that mean? These two have to be not so far apart. So is any sampling method perfectly unbiased? The answer is no. But the bias typically creates a situation where these two are not that far from each other. And what we're saying by also far away, that the difference of how the two are, it doesn't really matter for the application we're about to use it for.